Friends, welcome back to my YouTube channel. I hope you're fine. In one of the earlier videos, I promised that I would be uploading chapter by chapter summary of book Refactoring, Improving the Design of Existing Code by Martin Fowler. So here I am. Today I will be discussing what is refactoring, when should you do refactoring, and how you should do refactoring. We all come across scenarios where we have to make changes in the code base that is already live and used by either thousands or maybe millions of users, and we think that, for example, a change in class hierarchy or moving around a couple of functions in one class to another would make a significant difference, whether it will make code more readable or it will more make code more flexible so that new features can be added very quickly. So but we are afraid to do that changes. This chapter and the second chapter basically talks about what is the safest approach to do those changes in a step-by-step way without impacting the code base software output. So we will discuss all those in details. I would also want to tell you that today's video would be long, so if you have free time, only watch in that. Consider also subscribing to my channel and recommending to others, liking, subscribing, and sharing channel basically helps channel to grow, and YouTube picks up and recommends it to others automatically. So since channel is not monetized yet, all these kind acts will help me a lot. So without further ado, let's start. Motivation or background about this book. um, Authors tell us a story about a consultant who visits a software company, and he looks at their code, central part of the system, and after spending some time in the code base, he comes up different suggestions or observation. He realizes that high level classes in central part of the system or the code base made some assumption which were carried on in derived classes, but the code did not suit to all subclasses and functions were heavily overridden. Uh, he realizes that slight changes to the superclass would have greatly reduced the need to override those. In other parts of the system, an intention of superclass was not properly understood, and behavior that was present in the superclass was duplicated. Also, in some other parts of the system, several classes did the same problem, and the code was duplicated in those subclasses where this could have been moved to one superclass. Consultant discuss all the issues with class hierarchy with the programmers. They quickly realize the problem and they decide to clean up the class hierarchy. After spending a day or so, they realizes that they are able to get rid of half of the code base. New code base is clean, and adding new classes to the code base is very easy. But project management, they were not pleased because they were running behind the schedule. They had a couple of new features to deliver in coming weeks and months, and the exercise that did these two programmers, it did not add any new feature to the existing code base. Yes, they agreed that new system is basically code base is clean, but they were supposed to deliver features, not they say that we are supposed to deliver features, not deliver or ship code that is more clean or please any academic or programmers. So consultant also suggests them that they should do similar exercise in other parts of the system, which will take another week or so, but it will not add any new feature to the system. Existing system also work fine. So management declines their request, and after like 6 months, project failed miserably in all major parts of the system. So they had to hire another consultant, which rewrites almost all the software from scratch, and he also insists on continuous code cleanup using refactoring. And but the new system or the new software team is very productive, and the team can easily add new features to the existing system. So making changes is quick and cheaper. The first consultant is the author of this book, and second consultant is co-author of this book. All the techniques that they employed of refactoring are discussed in this book, and today these techniques are pretty much industry standard. What is refactoring? It is a process of changing the internal structure of the software without changing its external behavior. By external behavior mean output of the system. If old system was an app, a calculator app, which used to return 2 plus 2 is equal to 4, new system, or after we do refactoring, 2 plus 2 would be equal to 4 as well. And if old system was 2 plus 2 is equal to 5, the new system will also return 2 plus 2 is equal to 5. It might be surprising to you, but we will discuss it in some other video as this behavior. It is also called a systematic approach to clean up code base that reduces the chances of introducing new bugs, and eventually it will result in improving the design of existing code. If you look at this diagram, refactoring takes a messed up, hard to understand and debug code and performs some operations which are called refactoring, and turns that code into a well structured and better designed code. So what are those operations or steps or refactoring? It might be uh, looking at a large function and taking some part of it and creating a new function out of it, or might be removing one property from a class and shifting it to another, and might be adding a new class to existing class hierarchy. All those minor improvements to the code base without impacting overall output of the system. These minor improvements means a lot, and all those improvements are done to make your code easy to understand, and adding new features can be added easily and quickly. So the question is when we should do refactoring. One of the myths in computer programming is that we write programs that computer can understand, but the fact is that it is the humans that look at code when we try to add new features. So If you look at code and it is hard to follow what it is doing and how adding new feature will interact with the other parts of the system, most likely you will be introducing bug in the system. So if you look at a code and it is, for example, a method that is expanded on 50 line and 100 line of code, so instead of adding new feature to it, first it is advised that you should break down into multiple functions so that you can understand clearly the intent of existing code. And once it is improved and you have made it more readable, then you should add a new feature to it. When not to do refactoring. If there is a part of a system or a software that you think that it will not change and it works fine, you can leave that and you should not apply refactoring. It is good to improve that, but if you want to leave it, that is also fine. But as soon as someone wants to make any change or try to understand and it is hard to follow, then you should realize that you should do something about it. Let's say we have identified an area in our code base that we want to change. So, what would be your first step to make that change safely? And in this chapter, it is advised that we should have a solid set of unit tests before we make any change to the code. Um, we should use testing frameworks that are available in almost all the modern IDEs editors to execute tests quickly, and it can you can run those tests with the help of just single command. Unit tests should take only few seconds to run, and you should run unit tests frequently. They act as a bug detector that will protect against introducing your own bug when you will try to change or add any new class. The time that you will spend in writing unit tests, it will save you hours of debugging. Based on my experience, sometimes I even don't test output and I just rely on unit test to verify that my changes work fine. For example, there is a screen that comes after like 5 steps. You log into the system, go to dashboard, and then go to another screen and reach the screen where you are changing. So unit test can save you that time as well. Uh, Always make a small change, test it to see if you have broken anything, making a change, and then you should commit it locally. Small commits can be you can squash those small commits into meaningful commit when you try to push your code to a repo where other people can look at it. If you will try to make a big change, making a mistake will lead you to hours of debugging. So it is recommended that always make small change, test it if it works and it does not break anything, then make a local commit. Following this procedure will save you much time while doing refactoring. If you make a small change and then commit it, using this procedure help you to recover. For example, if you realize that you made a mistake and you want to revert to old working state with the help of versioning control like Git or SVN, you can revert to old working state quite easily. So let's say you have made changes to the software uh, by refactoring techniques. What would be the output of the code or a state of the code after you have done small changes? Uh, Overall code after refactoring would be readable, modular, and it would be easy to understand. Because it would be easy to understand, then adding new features to support the system, it would be less likely that you will introduce bug. Also, there would be clear separation in terms of, for example, if there is a function, it will be doing one task. If it is a class, it would be taking one responsibility. So code would be in much better shape. There would be less repetition of the code. One side effect of the refactoring could be that it will lead to a performance loss. For example, and that in old code, for example, a function is being called once in a loop, and now it is being called more than once, 2 to 3 times. But as per the author, it is okay even if we lose a performance to a small extent. And in modern tools, you can run the instruments and you can check if there is a significant performance loss. But the argument is that a well refactored code is easy to tune in, especially with modern techniques like caching, and you can tune in performance better if code is in a better structure. Also, after doing these small changes, either you will result in less number of lines of code, or uh, you end up with having more number of lines of code. So it depends on scenario. For example, in old code you had 3 files of code, and now we after separating and making it modular, now it's 5 or 10 number of files with the code. So it depends on scenario to scenario. But we should realize that every time that we work on a function, we should, for example, if it is existing function, there is a rule which is called Boy Scout rule or camping rule, that uh, you should leave basically the code base healthier than when you found it. So I really like this idea that every time, for example, if you're making a change in the function, and other than changing that part, you are slightly improving it, and you are visiting it frequently and improving it every time, it will definitely improve quality of that function eventually. So then he also goes on and summarize this chapter that the true test of the good code is how easy and quickly you can change. For example, like adding a new feature should be easy to add without introducing error. And now we will look at like overview of the example that he took, and where he employed a couple of refactoring techniques. The author presents a scenario and takes a function which is like 50 lines of code, 50 to 70 lines of code, and then converts or makes small changes using refactoring techniques. Like he takes a part of this long function and converts into another function, and then calls from original function, and then he takes small pieces and converts into separate identifiable uh, functions. And he coins this techniques with name, for example, extract function, inline variable. He moves one function from one class to another class, and after looking at conditional statements, he replaced them with polymorphism to make future changes easy and quickly. And then once he has done converting all those functions into one function into separate functions, then he slightly separates them out into two different classes and make it easy, where one part is basically doing the processing and the other part is responsible for displaying of the output of the software. So this the first chapter. It is I found it very interesting the way he writes the book, that instead of presenting all those techniques and boring developer, first he comes up with the real time scenario and describes and gives a gist of refactoring. And after that, in next chapters, he will basically discuss one technique one by one. And that's how book is written, so that developers don't lose interest while reading it, which is good. In the end, I hope that you like this video. If you have any comments or suggestion regarding the videos, please let me know in comment section. And also do subscribe the channel and share it with others, so that YouTube algorithm can pick up my channel. And it also motivates me to create more and more videos and share it with you. Till next chapter, have a good day or night wherever you are, and bye bye.